First thing we need to understand is the physical limitations of Ethernet. The overall segment length has to be a certain distance. Depending on the type of cable you're using, as we saw in the previous section, you've got length limitations that you must adhere to. As you go a certain length, the signal will end up degrading, and depending on whether it's copper, which has a much shorter length than optical cable using fiber, that length will certainly vary. You've got roughly 1,000 meters when it comes to copper, and depending on the type of fiber cable you're using, you can go upwards of, say, a couple kilometers. All right, so that's the key thing. Let's take a look at what's next here. All right, so if we're extending these LAN segments, the overall LAN segment before it hits a repeater of some kind, at least with copper, is 100 meters. So if you've got a repeater sitting in the middle, then we can go 100 meters from any direction from that individual repeater. Now, a repeater is also called a hub in Ethernet speak. Now, what a hub really does electronically is that inside of the hub, it actually emulates what we used to do in Ethernet with the older technology, 10 base 2 or 10 base 5. Now, 10 base 2 meant that it ran 200 meters, and 10 base 5 meant that it ran 500 meters. Now, a 500 meter cable was this thick yellow hose, and you use these vampire tap things to plug into it, but it was a bus-style topology. Cheaper net, or 10 base 2, also known as thin net, was a thinner coaxial cable. You'd use a T connector to plug your machine in, and you'd have a 75 ohm connector at each end of the cable to identify the endpoints. But yet an overall run of 200 meters. The problem again was that it was a bus style connector. So when switching over to 10 base T or 100 base T, we'd use repeaters that would emulate the action of a bus network by repeating the binary out every single port as it receives it. So as we sent data up to the repeater, up to the hub, it would repeat this information out all ports. So the idea of replication or amplification of the signal allows us to extend the segmentation of our 10 base T networks. Now, the problem with extending our LANs in this way by using repeaters is what happens when multiple devices try to talk at the same time. Ethernet isn't designed for that. Only one device on a particular LAN segment can communicate at any one time. So we have what's called a collision. If two devices talk at the same time, they collide, and we have to back off and have to set a jam signal and use this back off algorithm, and both sides essentially set a random timer. Whoever timer expires first, that's the one who gets to talk. The problem with collisions is you end up looking at graphs on Ethernet networks, and the more devices you plug into a hub, it slowly degrades the overall bandwidth of the network until you reach a point, and then it just flat out crashes. And then it drops to about no speed whatsoever because you're just getting too many or a high level or excessive level of collisions. So that was one of the reasons in the early days why a lot of hospital networks and other networks that needed to put a lot of devices on the network chose token ring as a better technology, because it was more predictable when you added multiple devices what the degradation of the network would become. So every time you added a device, you know immediately how much bandwidth you lost by adding one additional device onto the token ring network. The disadvantage, of course, with the token ring network was, what drives all decisions, right? It was all about cost. I put an Ethernet card in a PC and it's $10. I put a token ring card in the same PC and it's $120. IBM figured out, it's got an IBM name brand logo on it. Of course, it's going to be, 120 times more the cost. So there you have it. That's really the reason why Ethernet won the overall war of the local area network. Ethernet won flat out because it was an open standard. Everybody could make it if you were a manufacturer, and it's cheaper. So that given the fact, we had to deal with collisions. And in dealing with collisions, we had to deal with some ways to segment it to make sure that we didn't build our networks too large and have too many excessive collisions.